This video is for Algebra 2, it's lesson 7.2, and we're going to look at radical expressions. We're going to start by multiplying them. If the nth root of A and the nth root of B are real numbers, and this is a very important feature that you talk about the fact that they are real numbers, then when you multiply those two nth roots, they are equal to the nth root of A times B. And that's helpful when you look at our first examples. The square root of 3 times the square root of 12, the square root of 3 isn't going to be something that I can take the square root of easily. It is irrational. The square root of 12 is also irrational. However, when I multiply them using this property, I can get the square root of 36, which is rational. The square root of 36 is 6. And it is not plus or minus because I'm not implementing or putting the square root on. It is already the positive square root. In letter B, we're going to do the cube root. So again, I'm going to multiply those. 3 times negative 9 gives me negative 27. And the cube root of negative 27 is negative 3. Looking at the fourth root, however, the fourth root of a negative value, it is an even root of a negative number, therefore it is impossible. And it is impossible because even root of a negative number is not real. It is imaginary. So therefore, it is not something that we can use that property with. So now we're going to simplify each of these expressions using some of the ideas that we had from the previous section. But one of the things that these problems are going to have is they're going to assume that x is positive. And because x is positive, we're not going to have to worry about absolute value symbols. So let's look at simplifying the square root of 50x to the fourth. If we look at the square root of 50x to the fourth, we can take pieces of that away. Take the square root of 50 and break that into 2 times 25, and the square root, or x to the fourth, can still stay there. Then we end up with the square root of 2 times the square root of 25 times the square root of x to the fourth. And we can take the square root of each of those parts. So the square root of 2, we do not know. However, the square root of 25 is 5. And the square root of x to the fourth is x squared. So the answer is 5x squared times the square root of 2, and that's the most simplified version. The same thing can be true for the cube root of 18x to the fourth. You're going to take that cube out. When I look at 18, I know that I can divide that by 9. And I can divide that by 2, but that's not going to be helpful. 3 times 6, or 3 times 6 is not going to be helpful. But I look at that x to the fourth, and that's where I can separate it out. So the cube root of 18 stays in there. But x to the fourth can be x cubed times x. And so when I take the cube root of that, the cube root of x cubed is just x, so I pull that out in front, and I'm left with the cube root of 18x on the inside. In the next example, we're going to multiply this example together. I'm going to look at everything that's on the outside of the radical. The 3 and the 2 can be multiplied, so I end up with 6. Then I can multiply everything inside that radical. So I end up with 7 and 21, and 7 times 21 is 147. And 147, then I get x cubed times x cubed, which becomes x to the 6th power, and y squared stays underneath that. So now when I think about this, I go back to how can I simplify this? Is there a root that I could take out of 147, out of x to the 6th and y squared? So I go back to my original problem and I look and I know I have a 7 here. And I also know that I have 7 times 3 and 21. So I know that I had originally 7 times 7 times 3. Well, 7 times 7 is 49. So I'm going to re-look at that. And I'm going to break 147 down to 49 times 3. Then this x to the 6th can be broken down. X squared times x squared times x squared. And I've got y squared. And then I'm going to take the square root of each of the pieces that I can. So 6 just stays on the outside. It gets multiplied by the square root of 49, which is 7. I can't do anything with the square root of 3. And I'm just going to rewrite these as I get them. The square root of x squared is x. The square root of x squared is x. The square root of x squared is also x again. And the square root of y squared is y. Now that I have taken the roots of each of the pieces that I can, I'm going to simplify what I have left. 6 times 7 is 42. X times x times x is x cubed times y. And I still have all of that times the square root of 3. Again, one of the nice pieces about this is that we are assuming that all variables are positive, so we don't have to deal with the absolute value in these simplifications. The biggest thing is to go step by step and break them into pieces that you understand. You do not have to break it down to x squared times x squared times x squared every time if you understand that the square root of x to the 6th is x cubed. So moving on, we also have the dividing radical expressions, which is kind of the same idea with real numbers. And this time we also have the exception where b cannot equal 0. You do not want to divide by 0 because that is undefined. So again, the nth root of a and the nth root of b are real numbers, and b cannot equal 0. Then when you divide the nth root of a by the nth root of b, that's the same thing as the nth root of a divided by b. Again, it allows us to combine some things that make it easier to take the root off. So when I look at 243, the square root of 243 is irrational again. And so I want to understand that let's check to see if 243 is divisible by 27. 243 divided by 27 is 9. So when I rewrite that, I'm going to rewrite that as the fraction, and then it's rewritable as the square root of 9, and we all know that the square root of 9 is 3. We're going to do the same thing with letter B. Take the root of 12x to the 4th all over 3x. We're going to simplify that, so we get the square root of 4. X to the 4th divided by x leaves us x to the 3rd. Using the multiplying radical symbol, you can rewrite that as 4x squared times x. And so now when you rewrite this, take the root of 4, you get 2. The root of x squared is x. You get the square root of x left over. So 2x times the square root of x. Doing the same thing with the 4th root. We've got the 4th root, put everything inside one radical. And now I'm going to divide that 1024 by 4. And I end up with the 4th root, 256. X to the 15th divided by x gives us x to the 14th. So I can rewrite that again. 256, something that would be divisible by 4 is going to be 12. And I would have x squared left over. And then I would take the 4th root of 256 and x to the 12th. So the 4th root of 256 is 4. The 4th root of x to the 12th would be x cubed. And then I'm left with the 4th root of x squared.